Hey class, welcome to week 12. This week we'll be doing a new topic, so getting away from probability and doing something different. We'll introduce the topic with what's called camp bucks. So there's an explanation of it here, but basically it's a math camp and they don't accept regular money or credit cards or anything like that. So before you get there, you have to purchase some what are called camp bucks. And they're only in two denominations, in this case, $4 and $7 bills. Okay, so you can buy things at the camp, but you're only allowed to use $4 and $7 bills. And you can get change, but the change is always in $4 and $7 bills. And the cost of items are always going to be whole numbers. So you'll never have any decimals or anything like that. Okay, so the cheapest item is $1, right? Okay, so based off of that, for example, let's say you wanted to buy something that cost $10. One, is it possible? And two, how would you do it? So for a $10 item, one way I'm thinking of it is, well, I could give the cashier two $7 bills, which would be $14, and then receive one $4 bill as change. So that would be a net total of $10. Okay. So for each of these, explain how you would do it. Right? Could you buy something that costs $2? Experiment, with this, give and take fours and sevens. And it doesn't have to be, you're giving sevens and getting back fours, right? You can do a 4 and a 7 and get back whatever. So, I mean, just kind of experiment and see if you can come up with a way to buy each of these items. It may or may not be possible. So if it's not possible, explain why not. If it is possible, explain how you would do it. Okay. So the next part is then putting that in some math context and writing an exchange equation. So for my $10 example, my exchange equation would look like this, right? This is 10 equals 2 times 7 minus 1 times 4, because I paid with two $7 bills and then I got one $4 bill as change. So that's a subtraction, right? So change will be subtraction. If you pay for it, that would be addition, right? So maybe if you bought something and you paid two sevens and two fours and didn't get any change, that would be 2 times 7 plus 2 times 4. You paid it all, you didn't get change. So change is subtraction, right? You may or may not need change, so you may or may not have subtraction involved. Okay, so for each of the values from A through D, come up with your exchange equation and write it here. If it was not possible to make the purchase, then just write not possible here. Okay. Once you've done that, then see if you can come up with the cost of the cheapest item, right? So I would, start with $1. Can you buy something that costs one? If you can, that is the cheapest item. If not, how about two? How about three? How about four? So here, write down the cheapest item that can be purchased. Explain how you could just put the exchange equation and show that you can do it, and then show that you cannot do anything lower than that. And then can you find an item that cannot be purchased at this camp, right? Maybe like $4, can you not purchase it? Well, I guess you can because you have a $4 bill, but is there anything at this camp cost-wise that you could not be purchased? So if so, write an example down here. If not, explain why you can't find it. Finally, we'll do a different camp math with some different denominations, 6 and 9 in this case, and some similar questions. Can you buy it? If so, write the exchange equation and then end with what's the cheapest item that can be purchased. Okay. And that's it for assignment 18. Assignment 19 is going to continue with the same topic, just an extension of it and more exploration. So it's camp bucks part 2. So we're going to continue with the 6 and 9 denominations. And now we're really focused on what can be purchased and what cannot be purchased. So for each item cost here, just write yes or no. Yes means you can purchase it. You can come up with that exchange equation. No means it seems impossible with these denominations to make a fair exchange. Okay, so you should have a list of yes and no's there. And then really focus on the yeses. Like, what do the yeses have in common mathematically? Is there any pattern there with your yeses? Do the same thing with 14 and 16. Take it item by item. Can it be purchased or not? And then do the yeses have anything in common? Okay. Number 3 is just one more new denomination, 20 and 40. Find the cost of the cheapest item. What's the cheapest? Can you get a $1 item? No, 2, 3, what's the cheapest you can do here? And explain or write an exchange equation of that cheapest. And then how would you purchase a $136 item? Is it possible? Maybe it's not. Then explain that. If so, how would you do it? Okay. Give the exchange equation. Again, if you don't get any change back, there's no need to put the subtraction piece, just do addition, right? Like maybe I use 2 4s and two 24s and a 40, right? That would be 2 times 24 plus 40, done, right? Or maybe you did get some change. You used 4 40s and got 24 back. Does that work? Right. So there's multiple answers that are possible. So see if you can come up with one that works for the 136. Okay. Finally, let's look at cheapest items and see if there's a pattern with that. So here are some denominations that you've already worked with, those first 4. Just write down what the cheapest item was. You should have that in your previous assignments about your cheapest item for each of those. Here's 3 new ones. So explore with those and see if you can figure out what the cheapest item is at those camps. And then come up with 3 on your own. We're looking for a pattern here. So if you think of some denominations that may help with your conjecture at this point, try to experiment with those, maybe pick them sort of a way that's going to help you, and then write down your cheapest item. Okay. Finally, make a conjecture what you're seeing. Is there any relationship between the cheapest item and the denominations, right? Are you seeing anything that they have in common? Or there's a pattern there? Or given the denominations, you can just come up with the cheapest item by doing what? Right? Something like that is what I'm looking for. So make a conjecture based on your table. And that is it. Okay. And then the only other thing is a discussion post, which is about a movie from the 90s called Die Hard 3 with Bruce Willis and Samuel Jackson. And there's a math problem in that movie. And this math problem has a little bit to do with the Camp Bucks, just in a different context. So the problem is written out in the discussion post. So just read the problem and see if you can come up with the solution and then discuss it with your classmates. The clip of the movie is there as well. You don't really need to watch it, but it might be interesting to see the movie clip that goes with the problem. Just a warning, there's some bad language in the movie clip, so you don't have to watch it if you don't want to. It's just there for fun. So it's up to you if you want to watch it or not. But the blurb and the math problem is written out, typed out in the discussion post. So work on that for the discussion, and that's it. Okay, so hope all is well. Send questions my way if you have any. Otherwise, have a good week, and I'll talk to you next time. Thanks. Bye.